Well, welcome to this concept. If you'll take out your note packet, we're going to go ahead and get started with the notes for solving, writing, and applying one-step, two-step, and multiple-step equations. There's a little bit of vocabulary I'd like to share with you first of all. And the first word that we deal with a lot with equations is solve. So, what does it mean to solve? Well, when we solve, and you do want to jot this down, solve means to find the value of the variable that makes an equation true. Find the value of the variable that makes an equation true. And that's really what we want to focus on as we go through this, is we want to find the value of x or y or whatever variable we're using. Now, sometimes we're going to refer to this idea of inverse operations. So what does it mean to be an inverse operation? So first of all, let's go ahead and define that for you. So an inverse operations are defined this way. They are two operations that undo each other. Inverse operations, two operations that undo each other. Now, inverse operations, the two that we're going to use is we're going to refer to addition and its inverse of subtraction, meaning addition and subtraction undo one another, and multiplication and division do the same thing. They undo each other as well, and they are inverse operations. All right, so let's take a look here at solving one-step equations, thinking about inverse operations. So right away here, we have an x, and we want to try to get that x by itself. So what we have is we have this adding 7 to x, and we need to undo adding 7. So to undo adding 7, we can subtract 7, and we do it from both sides. So the way we show this is we subtract 7 on the left side and 7 on the right side. Sometimes, if you want, you could put a line down the middle so that way you know that what you've done to the left side, you've also done to the right side as well. It's not necessary, but you sure can. Now, I like to put a line underneath here because it shows what I'm about to do next. So a positive 7 and a negative 7, those undo each other. So I'm left with x equals, and negative 4 minus 7 is negative 11. Now, if I put negative 11 right here back in for x in the original, do I get a true statement? Well, we can check that. I would have negative 11 plus 7 equals negative 4. And that's true, so we've solved this equation correctly. We don't ask you that you check each one, but it is good to check just to make sure from time to time that you're doing things correctly in terms of the operations. Here's our next one. Now notice on the middle one here that we have an x on the right side of the equation. Doesn't matter where the x is, if it's left or right. So I need to get rid of the negative 12 that's with the x. And so I'm going to undo that by adding 12 to both sides. So I'll do it to the left side and the right side. I'm going to draw my line, and negative 12 plus 12 is 0. So I'm left with x is equal to 3 plus 12, which is 15. Now I could also write that, if I wanted to, as x equals 15, and generally that's how we're going to do it, is with the variable on the left side. So You've seen the inverse operations of addition and subtraction at work. Now let's move on. Over here, we happen to have negative 6x is equal to 48. Well, what I have is I have a negative 6, and that's times x when it's bumped up right there. So that coefficient of negative 6 needs to become a 1. Now, one thing you'll notice is that the number in front of x, there isn't one, but technically there is. It's a 1x. And what we want to try to do is we want to make this negative 6x so it's a 1x. So we're going to divide both sides by negative 6 here, because negative 6 divided by negative 6 makes just a 1x on the left side. And 48 divided by negative 6 is negative 8. And here we use the inverse operations of multiplication and division to undo one another here. We can also do that in the next two as well. And so I'm going to go ahead and take those away from us for just a moment. And let's go ahead and take a look at these last two. Now, if we take a look at 2/3 x is equal to 40, that is 2/3 times x. And again, I need this 2/3 here just to become the number 1. So I have to think about fractions, and I have to think, okay, what could I multiply 2/3 by to get an x? Or, if you think of it this way, since 2/3 is being multiplied by x, I could divide both sides by 2/3. Because 2/3 divided by 2/3 is 1. Now that gets a little messy with fractions, so let's go back to original idea. What could we multiply 2/3 by to get just 1? Well, we can multiply 2/3 by its reciprocal, which is 3 halves. And I'm going to do it to both sides. Now, I'm going to write this 40 as 4 over 1. Now, the reason I multiply by 3 halves is watch what happens on the left side. 3 times 2 is 6, and 2 times 3 is 6. So I get 6 over 6, which is 1. Or I can cross all of these out, and I get just 1 since I'm just left with x. Now, I can multiply 40 and 3 on the right side and 2 times 1, but also multiplying fractions, I am allowed to take 2 into 40 20 times, and I'm left with 20 times 3, or 60 over 1. Okay. Now, on this final one over here, we have to get rid of that 7 on the bottom. Now, this is x divided by 7. So the inverse of division is multiplication to both sides. And I'm going to show multiplication by putting that in parentheses there. So 7 times negative 3 is negative 21. And if you're dividing by 7 and multiplying by 7, they undo one another. So you're left with x. X equals negative 21. And we can write it either way. Like we have, or like this. Now, solving two-step equations requires us to get the variable term by itself first. So what I want to do on this down here is I want to get the x over 4 by itself first. So I need to move that positive 2 to the other side. So the inverse of adding 2 is subtracting 2. So let me do that. Subtract 2 from both sides. I'm left with 24 is equal to x over 4 because positive 2 and negative 2 cancel themselves out and become 0. Now I'm dividing by 4, so the inverse of dividing by 4 is multiplying both sides by 4. And the 4s will disappear and become 1 on the right side. 24 times 4 is 96. I could check that if I wanted to make sure I was doing it right as well. The last solving two-step equation one I want to look at is negative x minus 7 equals 2. Now, again, I want to isolate the variable term first. So that negative in front of the x stays with that x for now. So I'm going to add 7 to both sides. Negative 7 plus 7 is 0, so I'm left with negative x equals 9. Now, think of that negative x as a negative 1x. And I could do a couple different things to get that -1 to become a +1. I could divide both sides by -1, just like so. Or I could multiply both sides by -1. In either case, I get -9 for a final answer there. So the way I could check this one is if I plug this in for x, it would be a negative, and then where I see an x, I'm going to put -9. Then it's -7 equals 2. So negative times a -9 is +9, and 9 minus 7 is 2, and that is definitely true. And hooray, we did it right. So a lot of times we'll give you a lot of equations to solve, but as you move on in math, you're going to have to write the equation first and then solve. So last thing, you have $40 to spend on some school supplies. You need a calculator that costs $15 and also need notebooks. We know each notebook costs $3, and how many notebooks can you buy, not including tax? Okay, so the unknown that we have here is we want to figure out how many notebooks. So we're going to refer to that as our X. Okay, so we know we're going to buy a $15 calculator, plus we're going to spend $3 for every notebook we buy, and we've got to see if that'll equal 40. And again, we're trying to see how many notebooks we could buy. So let's solve this. So again, we're not going to touch this positive 3x. Okay, that's going to stay put. That plus goes with the 3. So first thing we're going to do, what do you think? If you're thinking subtract 15, you are absolutely right. So this becomes 3x is equal to 25. Now, the inverse of multiplying by 3 is to divide by 3. So I'm left with, well, x is equal to 25 over 3. Which doesn't come out nice, does it? But 3 goes into 25 8 times with 1 left over as a mixed number. So I can't buy 8 1/3 notebooks, so I have to reason this out. Can I buy 8? Can I buy 9? Well, the correct answer is 8, because if I buy 9, that's going to be too much. And you'll talk about this later on in the next unit too. So 8 notebooks is what I can buy, and I can label that as 8 notebooks as well, because that means I've read the problem correctly, and that's the correct solution labeled as well. So that is a little bit of a look at how we can go ahead and solve 1-step equations, 2-step equations, and if I can get out of this ever, and how to start solving some multi-step equations. So we will see you next time on the next video. Tune in to the next part here in just a moment.